Good morning, students. In the CT part, while doing the problems, we stopped at something around 117, I think, around 11 triple one. Okay. These were some of them problems like 120th I have to discuss, 121 I have to discuss, but I will discuss after this lengthy problem. 124th question I am discussing now, afterwards I will come back again. Here question number 124, this is very important one for the competitive exams other than KSET, not for KSET place, okay, because more steps are involved, no, just 3 steps up to 2 or 3 steps only for KSET, other than that is not for KSET. It can be asked for Neet or JEE advanced cases. A JEE main also very rare, JEE advanced they may ask. So in this case 4 charges minus q are at 4 corners of a square of charge, and charge small q is at the center. At the 4 corners of a square the charges are minus q, minus q, minus q, minus q. Everywhere you have minus q. Here also minus q. Let us imagine ABCD are the sides, corners, and side length, each side length is, let us imagine they didn't give us, let us imagine L or A or R, that is left to your choice symbols because that will be cancelled later. Side length is A. If length is A, then diagonal becomes equal to A root 2. Pythagoras theorem we can use A and A, theta 90 degrees, no, so this will become equal to, hypotenuse becomes equal to A root 2, you will get total length. But from center to any corner the distance becomes equal to A by root 2. This is A by root 2, this also becomes equal to A by root 2, A by root 2, this is also A by root 2. Next, all negative charges are there in any system. System means collection of the charges here with some separation. In any collection system of the charges, if all are like charge, same kind of charges, all minus or all plus, okay, there will be always instability in that arrangement. That means all negative means repulsion, they try to go to infinity. And if all are attractive means they come to meet it. All are positive means repulsion. So compulsory, if you want to make it equilibrium, you require some positive charges, some negative charges. Then attraction balanced by the repulsion, the net force can become equal to 0. Where net force 0, we said is equilibrium. So in this case, all are minus charges are at the corners. If you leave only these 4 charges at the corners, due to repulsion, they will try to go to infinity. Okay, but if you keep one more charge in the center here, which is supposed to be positive charge, then it can attract all 4 charges. When repulsion is balanced by the attraction, then the system can be in equilibrium. For the purpose, you have to take any one charge and find the net force on that charge and equate that equal to 0. Well, I am taking this charge minus q at a D. The minus q, between these two minus q repulsion will be there, that is in the direction. I have taken that as a F1. What is F1 equal to? F1 is nothing but equal to q1 q2 by 4 pi epsilon into distance square. So q1 q2 is minus q into minus q becomes equal to q square by 4 pi epsilon into distance square is a square. Same way, even if you take this other charge at A and D charges, minus q only, repulsion. Distance is also same. When distance charges are same, force is also equal. But direction you have to be careful here. F2 is in the direction, F1 is in the direction, theta is 90. Repulsion forces 90. So theta is 90 means that under parallelogram law if you take, no, the resultant becomes equal to F1 square plus F2 square plus 2 F1 F2 cos 90 is 0. But F1 equal to F2, the result is F1 root 2 you have to get. So what you get here is F1 and F2 are same forces, equal to magnitude is q square by 4 pi epsilon naught, this epsilon naught into distance square, a square you will have. Okay, and F1 is perpendicular to F2, therefore the resultant of F1 and F2 we are written as a F12 is nothing but equal to F1 root 2. F1 is this value into root 2 term comes extra for us. Next is, because of these charges over this 4th corner, that is B, charge at B and D, consider these 2 charges, no, minus q again. Okay, but distance is not same, it is nothing but equal to a root 2 diagonal length. A root 2 is the distance. So what you get, the force is nothing but taken as F3. What is F3? F3 is along the diagonal like this. And F2, F1 are equal magnitude means it makes 45 degrees. Means along the line extension of the diagonal only you will get F12 also and F3 also. Because of this B, force is F3. What is F3 equal to? Q1 Q2 means QB QD by 4 pi epsilon into distance square. Distance is a root 2. A root 2 square means a square into 2 you will get. Repeat. F3. This is because of due to B and D opposite corners is equals to along the diagonal. Minus q to minus q by 4 pi epsilon 2 diagonal length is a root 2 square. root 2 square is 2 only, 2a it becomes. So a square remains. Q square by 4.2, this root 2 is 1 by 2, it comes on squaring it. This is nothing but equal to F3, but from diagram you have to check up F3 and force because of 1 and 2 same direction. Because same direction, no, when force are in same direction added, opposite direction is subtraction, simply we can take. Any other angle is given means you take the help of the parallelogram law. But here same direction means theta is 0. So resultant of this F12 and F3, we will take it as F13 is nothing but equal to sum of the two forces, F12 plus F3. So what you get the force is F1 to F3 same direction, therefore resultant is F123 is equals to F12 and F3, that is this force and this force are added in the same direction. The result is q square by 4 pi epsilon square a square, you can take out common. Q square by 4 into a square root 2 plus q square by 4 into a square into 1 by 2. This part you can take out common, you will get is root 2 plus 1 by 2 you will get. Okay, taking out common. So resultant, overall resultant of the forces on the corners of a square is F123 is equals to q square by 4 into a square into root 2 plus a half. You can take LCM here only if you want, later also we can take. But next is force because of small q at the center and D. At the center point I am taking it as E. So between E and D distance is a by root 2. I am taking that force as F4. It is supposed to be what direction to keep this q in equilibrium. This charge in equilibrium, the repulsion force is this side, so attraction force should be exactly opposite side. That I take it as F4 in the diagram I am mentioning it. So that value, that relation we take it as a net force equal to 0. So we don't know, thinking that we don't know what is the direction, no, we put the value here, formula as it is here. So what you get here is F4. F4 becomes equal to Q. F4 is nothing but equal to this between these two forces. Small q into minus capital Q by 4 pi epsilon naught into a by root 2. This distance is square, a by root 2 square. So a by root 2 square is a square by root 2 becomes equal to 2. So 2 go to the numerator. So you will get is minus q by 4 pi root 2 a square you will get, including directions. But net force is 0, equilibrium condition is given. At equilibrium net force is 0. So that means overall force you have to take. Overall force is nothing but equal to this force plus the force because of this center charge, that is nothing but equal to F4 is equals to 0. Okay. Then you calculate the value of, you can take directly also. Instead of taking this plus equal to 0, you can also mention that this force equal to this force, directly you can mention it. But if you take like that, no, you must take the magnitude of the forces. I am not taking that way. So what you take is nothing but equal to this force plus this force is equals to 0. And this the common terms, q by 4 pi into a square cancels. One q cancels here, one q cancels here. Left out is small q, take it to the right side is plus. So this 2 will be there, 2q will remain. And this q, if we equate, these 2 go to the left side. Here LCM if you take, no, 2 root 2 plus 1 by 2 it is. 2 root 2 plus 1 by 2. This take it to the 2 to the left side, it becomes equal to 4. The result is q by 4, 2 root 2 plus 1 or 1 plus 2 root 2 positive charge. Compulsorily supposed to be positive charge. In case if I have not taken this way, you can simply take every formula for the forces. Actually for Coulomb's law plus only we can take and just equate. This force is supposed to be equal to this force. You will get the positive term only. And the result is q by 4 into 2 root 2 plus 1 is the answer for us. Okay, in between problems you can easily work out. I want you to work out next, but 121 I have to work out. That is important ones. This question number 121. Refer to the diagram. Find the capacitance between the terminals A and B. Each capacitance value is 3 microfarads. In figure or circuit diagram, find the capacitance between A comma B points. Each value of C is 3 microfarads. Each value is 3 microfarads. This arrangement is important even for the resistors. Mostly this problem will be coming in referring to the resistors. We are taking the 3 capacitors looking like a series. They are not actually series. This terminal is connected to this terminal and this terminal is connected to this terminal. So, we will take the terminals points A and B. Each one A, C, C, C. Resultant you have to check up. You always remember this. These 3 capacitors come in parallel, please, not in series. Okay. These lines are nothing but the wires. Wires can be bent. Okay. This wire is there. So, if you take this wire like this, it is connected. We can rotate this capacitor. So, I am taking these 2 points first. I am taking these 2 points. Okay. These 2 points, center capacitor, you take it as this. This is center capacitor. Okay. This point, and then this same capacitor you are tilting like this. It is like this, you are rotating like this, so that this A will go to this side. That means now I am connecting, this capacitor will be tilted. This capacitor will be tilted and becomes like this. This plate goes to this side and this plate remains this side only. So, you will get the capacitance like this rotated. This is rotated like this. So, this terminal remains as it is, but this A go to the right side. This A is here now. This point is here. And this point is this one, 1, 2. So, left side is 1, right side is 2 remains. And third capacitor. Okay. Next, third capacitor. This third capacitor is connected like this with a wire. So, I can fold it in this way like this. When I am folding in this direction, this capacitor comes below this. I will take this capacitor below this. Okay. This B going to the left side and join to 1. B is going to left side and join to 1. So, this B going to left side and join to 1. And this part remains as it is. This is kept it like this, means this terminal is same, given like this. Okay. So, between A and B means this A, this whole is connected together. So, this all is A only, and this whole is connected together with a wire. This all is B only. Reverse it becomes, that is it. But between A and B, what is the capacity? They are coming parallel. Parallel combination, addition, you have to take C1 plus C2 plus C3, all identical. C plus C plus C. They look like series, but actually they are in parallel. C, C, C. All capacitors, this is the answer. All capacitors means 3 only are in parallel. Therefore, resultant between terminals A comma B is CAB. Parallel means you take it addition, 3 are there. So, 3C, C plus C plus C. But each capacitance how much? 3 microfarads. So, 3 into 3 microfarads, which is equals to 9 microfarads is the answer. C is 3 microfarads each. So, CAB answer is 9 microfarads. Similarly, you will get the resistors connections later topic. There also you have to take all in parallel. But parallel resistors is R by 3. Capacitance parallel capacitance is NC. That is C by N. N is 3 capacitors here. Next is 129. This problem also, this last page problems are for JEE purposes or IIT main or advanced, most of them, but some questions, only few questions I will tell you, they are important for the KCET also. In between what I left out, you can easily work out for the null points, capacitors within dielectrics in between. Okay, those we can, how much charge passing when two spheres are connected. We already done the similar problems before, you can work out those problems. Next question number 129. A fully charged two thin wires, rings, each of radius r are placed a distance d apart. Two rings, this one right here. We are given two rings, two thin wire rings with the radius r are placed a distance d apart with the axis coinciding, same axis, coaxial we call them as. The charges on the two rings are plus q and minus q. The potential difference between the two centers of the rings is how much? Two rings, each of radius r are separated by distance d, coaxially means same axis, coaxially. The charge, they possess the charge plus q and minus q respectively placed. Find the potential difference between the centers of the two rings. They have charges plus q comma minus q respectively. Find the potential difference between the centers of rings. Find the potential between the centers of two rings. You are given the two rings, axis is same, and same size also. The rings have the same radius r. This is the axis of the rings. And at this center, potential because of this charge, one is you take plus, another one you take it as a minus. The radius, this radius is nothing but equal to r, this radius is also equal to r. For ring at the center, potential is how much? Ring, for ring, if you take the ring like this with a charge q, V center, radius is say r, V center equal to q by 4 pi epsilon into r. This point you have to remember, please. At the center of the ring, potential is q by 4 epsilon into r, but E, electric field at the center of the ring is 0. At the center we are telling, this V at center, similar to that sphere. Sphere charge at the surface means potential is same everywhere inside, no, applicable for the ring also. If you take a loop wire, if you take this as a ring, okay, charges are there on the surface. The center of the ring, potential is V equal to q by 4 pi into r, not everywhere, only at center. And what about electric field? Electric field is 0 at the center, other places electric field will be there, but the potential electric field is 0 exactly at the center only. But in this course electric field is not required. V center is this formula, radius r if you have taken is r, and electric field center is 0. That is for the ring place, charged rings. Ring with the charge plus q or minus q does not matter. So for this potential I will take the center, we have to take this because of this, that I will take it as a. Okay, I will take it as a and that is equals to VA. and because of the center I will take the ring as B, and the potential here is VB. This is B, this is A ring I am taking. Okay, next. But potential here is not only because of this, potential here is it is effect also there. How much effect is that you have to check up? The distance between the center to centers is, I am taking it as a D. D is the distance between the centers. Center to center you have to take the distance equal to D. Okay, then what is the distance from here to here becomes? It is right angle triangle. So this R, this is D. This becomes equal to under root of D square plus R square it becomes. And from here to here also same you will get. This is also equal to under root of D square plus R square will be there. Now potential is a scalar, not vector quantity. So what you take is here at this point at A, potential because of this plus Q is Q by 4 pi epsilon naught R plus potential because of this is minus Q by 4 pi epsilon naught, this distance you have to take. This distance how much is under root of D square plus R square. Okay. Similarly potential at B. At B the potential is because of this charge is minus Q by 4 pi epsilon naught R plus because of this charge, this is the distance. Okay, not only charge here, everywhere it is charge is there, but scalar potential, no, if you take the ring, okay, not related to the magnetic field, so we calculate the magnetic field on the axis, but here potential at any point if you have taken at this point, no, charges are only at this tips of the ring. Charge potential at this point means because of one charge here, potential is V1, because of one charge, potential V2, all equal distance on the axis point, that the distance is smaller if I take. Okay, this is capital R, this is a D. At this point this distance becomes equal to under root of D square plus R square. So every point on this, if you take that under root of D square plus R square, the potential of all these added only, the resultant potential is nothing but equal to sum of the total charge you have to take. Total charge is Q only. This Q is not here, it everywhere total charge it is. So at this point you are taking the addition of all these charges. So on the axis if you take, no, this is at the center I gave you. On the axis if you take the potential on the axis of the ring with the charge Q, this is the distance is smaller, this is capital R, this is D, then this becomes equal to under root of R square plus D square. At this point if you take, no, V axis is equals to this Q by 4 pi epsilon into this distance you take it, the distance is smaller, that means V axis is equals to Q by 4 pi epsilon naught under root of this D square plus R square. D square plus R square. This is the formula for potential on the axis. Okay, this is the potential at the center. This term we are going to use there, but here two rings are there, you have to take the addition of those two potentials. So what is the potential at A, center of A? At the center of A, VA I will take, is equal to, because of this charge only, that is Q by 4 pi epsilon naught into R, and because of other ring charge is minus Q by 4 pi epsilon naught into this distance. The distance from this other ring is root of D square plus R square under root. Okay, you can take out this common out, or else later also we can find out, difference we need to find out. That time also you can take. Next is at center B. At the center of B, at the center of B is VB is equals to, because of this charge, that charge is negative here, minus Q by 4 pi epsilon naught into R. Okay, and because of the other charge it is a positive, plus Q by 4 pi epsilon naught under root of D square plus R square. You are asked to find out a potential difference. Potential difference means VA minus VB. I will write that point here. Potential difference. Potential difference between centers of A comma B is delta V equal to VA minus VB. You can take VB minus V also, does not matter, result if it comes minus, take it as a magnitude. This becomes equal to Q by delta V equal to VA minus VB. VA is Q by 4 pi epsilon naught into R minus Q by 4 pi epsilon naught under root of D square plus R square minus, this is VA minus VB. So when you take minus, no, this becomes minus of, minus becomes equal to plus. So this becomes is minus of VB. I am writing the step as it is, 4 pi epsilon naught under root of D square plus R square minus Q by 4 pi epsilon naught into R plus Q by 4 pi epsilon naught into under root of D square plus R square. The result is this becomes equal to plus Q by 4 pi epsilon into R minus Q by 4 pi epsilon into the root of D square plus R square. This becomes equal to plus Q by 4 pi epsilon to R minus Q by 4 pi epsilon naught under root of D square plus R square. You can take out this Q by 4 pi epsilon term. This same, this also same. You can take it as a 2 times 2Q by 4 pi epsilon into R minus 2Q by 2 under root of D square plus R square. You can take out this 2Q by 4 pi epsilon naught common, 1 by R minus 1 by D square plus R square you will have. I think option is given up to this only, or LCM also given sometimes. Q by, okay, 2Q, 2 cancels, no. Option is up to this only. So 2 by 4 is taken as a by 2. The result is Q by 2 pi epsilon naught into 1 by R minus 1 by D square plus R square. Is the answer. Is the potential difference between A and B. That is the second option. We'll stop now because the problems takes more time to explain. We'll stop now here.